Excellent. Well, thank you very much. It's a real pleasure to be here. I'm normally based in Silicon Valley, but I heard the previous presenters talking about bots. I'm also going to talk about bots, but physical robots. So I'll give you a bit of a journey in the industrial space. So first of all, ABB. When I live in the Bay Area, people always assume I work for Airbnb, but I work for the ASEA Brown Boveri company, which is a very large maker of industrial and electrical equipment. And the company is about 130 years old. So in some sense, when we talk about the various industrial revolutions, our company has been there at the beginning of the steam era, becoming electrical then transitioning. You'll see that in a moment. Some of the things we make industrial robots. We're the second largest maker of those robots. We make electric vehicle chargers. We're a key supplier to the electrical infrastructure of cities and data centers. So essentially, if you follow electrons through their life cycle, we're typically involved in some way, either moving those electrons or turning those electrons into motion. And therefore, our customers are involved in this massive transformation called the Fourth Industrial Revolution. But if we think about what it means, we're basically translating muscle power into steam, steam into electrical, and in fact, people mistakenly assume that the Fourth Industrial Revolution is just the advent of computers. But the reality is we've had computers used in factories since the 1970s in terms of SCADA systems, distributed control systems, and increasingly, much of the hardware we make is extended and augmented with computers. What is different now is a little bit like the metaphor of the human brain. So the human brain is really two brains. You have the reptilian brain, the limbic system, which is fight or flight, responding to instructions. And then we have the cortex, which is the system that plans and learns. And the key innovation in the last couple of years is, of course, AI, machine learning, the ability to make machines that not only follow instructions, but that increasingly can learn from their environment and continuously adapt. So when we think about the use of AI, the obvious use case is to think about AI in terms of making the machine smart in its operation. However, we're also using AI in much earlier stages of the value chain, and let me give you just a few examples. So a company like ours, we have a lot of products. We have 1.3 million individual stock-keeping units. And so therefore, it can be quite confusing when you're deciding to order something. So clearly, in the very early stage, we're using AI as a recommendation engine to say, if you bought this, you might also be interested in that. And that's very common in e-commerce, but it's particularly relevant when you have a lot of different products, and those products can be highly technical, and they evolve quickly. But we're also using AI in some more sophisticated tasks. So the electrical engineers who design the infrastructure for hotels or convention centers like this one, they create what are called line diagrams. We can scan those paper diagrams and actually interpret the equipment that people have drawn on those line diagrams and turn that into a pre-prepared order that goes straight into the e-commerce system. And then in the middle, we have what we call digital projects. When we think about an electrical substation, it takes 14 months to design and build a substation. Much of that time is not the building. It's the collaboration between the architects, the construction companies, and the suppliers. We're using augmented reality today to bring people into a virtual world where they can collaborate in 3D in real time. The next step is to use AI to say, why are we starting with a blank canvas every time? Why can't the AI system, based upon how much power you want, the size of your substation, pre-populate the design based on best practices that we've garnered elsewhere? And then lastly, we're using AI in the operations of our machinery. Everything from predictive maintenance to trying to optimize the energy efficiency of our products. But I'll give you some more specific examples. The evolution we're on is not to become a software company. We started with copper and iron. We added motors and drives. We added robots and sensors. What we're really on is a journey to become a cyber-physical company. The combination of software technologies, with hardware technologies. And we think it's this combination that is powerful. Because software alone cannot interrupt current. Software alone cannot lift heavy objects. Software alone cannot charge your car. So we believe in this combination. And the best way to think of the digital component is think of it like a nervous system. In addition to the muscle and bone, we create a system that can sense, analyze, and act. And let me give you some examples of the kinds of automation or the use that we're putting this AI technology to. So here in Singapore, population growth has stagnated. The population is getting older. So as a result, every company is interested in looking how to get things done with fewer people. And the first jobs that will be automated will be the 3 Ds, the jobs that are dirty, difficult, or dangerous. And no better example than in oil and gas. So today, in many parts of the world, you have these offshore oil rigs with crews manning the rig, and of course, then drilling for oil below the sea. So ABB has embarked on a project where we take the entire platform and we submerge it and put it right on the sea floor, 3,000 meters below the surface of the sea. Now, we put everything down there. We put the computers, the drives, the motors, the pumps, all of the electrical equipment is now underwater. So as you can imagine, you can't send for a support technician 3,000 meters below the water for a firmware update. So we need to have increasingly systems that manage themselves, that are autonomous in their operation. The second example you see here is an autonomous vessel. So today, we have an autonomous ship going between the port of Helsinki and a nearby island. Because in the world of tomorrow, more and more the supply chain of the world will depend on shipping, more and more goods will be shipped, we need more and more crews, but it's an unpopular job. And what we'd like to suggest is that increasingly, those ships will have fewer people or no people, as they will be largely unmanned. We also need more robots. So when people tell me, Guido, are the robots going to take all the jobs? The robots are coming, and to some extent, just in time, because there's a lot of tasks where we need additional automation. So as the world of the cloud takes over, more and more computing moves to the cloud, we're creating a robot called Data Center Sheriff. And the Data Center Sheriff can unscrew servers, unplug disk drives, and replace componentry, because some of these data centers at cloud scale are so massive that it can be a full-time job just simply going around and removing equipment that has shorted out. Another example is what we call the motor crawler. It's a bit hard to see here, but this is a robot which is essentially as flat as a pancake. And electrical motors are typically these windings inside of a metal enclosure, but there's enough space between the windings and the enclosure, so we can send this robot in between this air gap, and it moves inside, and it can inspect for circuit, for basically shortages, things that have broken inside of the motor or that are starting to degrade and then need to get fixed. The third example is what we call the transformer diver. Electrical transformers exist in 2 types. One of the types is sitting in a bath of mineral oil. And if you want to inspect this transformer, you typically have to drain all of this oil, lift out the transformer, do your inspection, and then drop the whole thing back in. What the transformer diver can do is it's a little submarine. It's literally about this big. And it has cameras, and it's controlled via Wi-Fi. And you can essentially go and inspect the inside of the transformer, leaving the mineral oil in place. So the inspections can be done more quickly. And all of these tasks are done by a combination of people and smart systems that analyze the images and look for defects or anomalies. The last one is a plant helicopter. Typically what we do with this one is we look for visual defects as well as detecting methane and various other gases to help factories comply with their emissions controls. And so in conclusion, one of the things that people ask is, well, so if these robots are getting more and more capable, will they take all the jobs? And what we believe is just like the combination of the future is cyber-physical, the combination of hardware and software. We also believe that in the case of AI, the most powerful combination is when we combine the human and the AI. what we call a humane. And we chose that term quite deliberately because hopefully we make ethical AI that can act in the best intentions of the people as well. But the reason why we think this combination is powerful is that even with all the progress we've seen in AI systems are brittle. They work well in the training set of data that they've been trained upon. They don't perform well. In fact, they behave erratically when exposed to black swan kind of events, unusual events. And this is where people do really well. We are supremely adaptable. We see things in context. So an example of this is in the case of, for example, in healthcare, all kinds of AI systems have been invented to diagnose human conditions. And before coming to ABB, I was with Nokia. We looked at all ways of using AI in healthcare. And what we discovered was that people fundamentally don't tell their doctors the truth. They lie. And so one of the most common cases is elderly people who go to see their doctor, not because anything is wrong with them, but because they're lonely. And if this was a pure AI system, and Mrs. Jones is coming to see the doctor for the 3rd time this month, it could conclude that, well, I've diagnosed you before that, you don't have malaria, you don't have yellow fever, you don't have dengue fever. Well, it must be something else, right? And just keep prescribing pills. But a human doctor knows this is an elderly person, they're alone, they like to come into the office and talk to the doctor. So this combination of the contextual awareness of an AI married to a human is really the most powerful combination. And so in conclusion, we're optimists about the future of AI. We need AI. We need AI to automate many of the jobs that are dirty, difficult, or dangerous. And what we believe is that the AI technologies have a rich future in the industrial world. Everything from how we sell, how we design, and how we operate the equipment that we deploy. Thank you very much.